Okay, so a survey of a group's viewing habits over the last year revealed the following information. Okay, so it revealed that 28% watch gymnastics, so the probability of watching gymnastics, right, is equal to 0.28. The probability of watching baseball, so the probability of watching baseball was 0.29. The probability of watching soccer, so probability of soccer is 0.19. The probability of gymnastics and baseball, so gymnastics and baseball was 0.14. The probability of baseball and soccer is 0.12. The probability of gymnastics and soccer, so gymnastics and soccer, was 0.10. And the probability of watching all three, so gymnastics and baseball and soccer, was 0.08. Okay, so now they want us to calculate the percentage of the group that watched none of the three sports in the last year. So they want the probability of G complement, right? Intersection B complement, intersection S complement. Okay, so let's draw a Venn diagram to see what this actually means. Okay, so let's see. So we have G, right? G, B, and S right here, right? So G complement is everything outside of G, right? Everything outside of G, including these areas, right? But we also want B complement, so that's everything outside of B. And we want S complement, which is everything outside of S. So notice it's everything not in any of these sets, right? So we can see here that this is the same thing as the probability of G union B union S complement, right? Because we know G union B union S, right, is this space here, and we want everything outside of that union, right? Okay, so now with probability, we know the probability of the entire space. So if this whole space was filled out, would be 1, right? So the probability of G union B union S complement would be equal to 1 minus the probability of G union B union S, right? It's 1 minus the stuff that we're not interested in, right? Okay, so the way we can write this is we can say, okay, well, this is equal to 1 minus, so we can do the probability of G plus the probability of B plus the probability of S, right? But if we do G plus B plus S, notice I added this area twice, right? Because G plus B means I add this area twice. So that means I have to subtract this area, the G intersection B. So I have to subtract the probability of G intersection B. Notice if I did S plus B, I added this area twice. So I have to do minus the probability of B intersection S. And I added this area twice. So minus the probability of G intersection S. And so now I have each of these areas once, right? Because before, when I added these three, I had these areas twice, but now I have these areas only once. But if I do minus G intersection B, minus B intersection S, and minus G intersection S, now I'm totally missing the intersection of all three. So that means I have to add the intersection of all three. I have to add the probability of G intersection B intersection S. So the great thing about this is I have all these values right here, right? So I know this is equal to 1 minus, so the probability of G was 0.28. The probability of B is 0.29. And I believe the probability of S was 0.19. Okay. And then minus G intersection B is 0.14. minus B intersection S. So B intersection S is 0.12. The probability of G intersection S is 0.10. And the probability of G intersection B intersection S is 0.08. Okay, so this gives us, this is equal to 1 minus 0.48. If you were to do all these calculations, it would give you 0.48. And 1 minus 0.48 is 0.52. So our answer would be there's a 52% chance that they watched none of the 3 sports in the last year.